In Notes 15, we're going to learn a new topic that's called ANOVA, but you're going to see pretty early on that it's actually just an extension of something that we've been doing since pretty early on in the semester. So this is going to be a technique that's going to help us when we want to compare two or more independent samples. And you might already be thinking, well, we've got a two independent samples t-test, so really the ANOVA is just an extension of that test that allows us to compare more than two groups at a time. So we're going to start this section of the notes by using an example and walking through the steps or sort of thought process of this ANOVA test without really worrying too much about the details, and then we'll fill those details in a little bit later. So for this example, we've got a company who wants to test 4 different package designs for breakfast cereal. So, if you go to the grocery store, you might notice that a lot of times the different cereal boxes have um, characters from movies or children's shows or things like that. And companies put some thought into which of those is going to sell the most for them. So for this study, there were 4 stores, or sorry, there were 4 package designs and 20 stores. And each of those 20 stores was randomly assigned to use one of these 4 package designs. So we had 5 stores for each design. You might notice that there's actually only 19 numbers in the table below. That's because there was a fire during one of the stores, and so their data didn't quite work with the study and they had to get dropped out. But the numbers that you see down below are the number of cases of the cereal that were sold. And so that's the thing that we're really interested in. And one of the other things that they did with this experiment was they tried to make sure that the stores they chose were pretty similar in terms of things like where they were located, how much they usually sold, amount of shelf space and things like that, because they really wanted to focus on just whether the package design mattered, and not worry about all of these other things that might also affect how much cereal they sold. So you can see right down here, here's the data, and you might already be starting to notice certain things by looking at it. But we're going to take a step back, and first we're going to say, okay, well, up to this point, if we wanted to just compare the population mean sales for design A to design B, what would we do? And I already said that we could do a 2 independent samples test, and we might do a hypothesis test, we might make a confidence interval, and at the end of the day, we might be able to say something like, I'm, 95% confident, or there's sufficient evidence that this package design has a different population mean sales than the other one. If we wanted to try to compare all 4 designs, that would be a little harder at this point. We might try to compare design A and design B, then do another test to compare design A and design C, and maybe we try to compare like every possible combination with different 2 independent samples tests. But you might already be realizing that that's going to be a lot of different tests and it might get a bit overwhelming. We could also consider taking the numeric values that we have here and trying to convert them into a qualitative variable. So maybe we call it like low sales, medium sales, high sales, and we try to do a chi-squared test to see if there's a relationship between sales and package design. But neither one of those is going to be really that satisfying. The first one's going to be a lot of work. The second one, we're kind of throwing away information to do it. So let's look at how we can try this new method to really answer this question in a way that we're interested in. And so to do that, I'm going to walk you through using this applet that's posted on the Moodle page and some data that I posted that includes what you see in the table above. So I'm going to go to our Moodle page, and if you scroll all the way down to the bottom, you'll see there's this link here that says Notes 15 applet. I'm going to open that up, and then I'm going to go and click on 15 applet data. For me, it just pops up in my browser. For you, it might download a file. But either way, I just want to copy the contents of the file. I want to go back to this link here, and I'm going to click where it says Edit Data. I'm going to replace this example and paste in my data, and I'm going to hit OK. And what you'll notice right away is over here, this is information about our sample. So this is information about the data that I just included. And you can see I've got package design A, B, C, and D. I've got sample means and sample standard deviations. So we might want to start looking at those and comparing what we notice. And if you compare the different package designs, maybe you notice that design D has the highest sample mean. It's also the most spread out, so we might wonder if design D really is doing a good job, or maybe there was just some random chance. Design B had the lowest sample mean, and we could kind of try and make other comparisons, but at the end of the day, what we've done with pretty much every test we've encountered is we've said, okay, there's a couple options here. This is happening because, for example, design D really is a much better package design, or it's just happening because of random chance. And every time we do a statistical test, our goal is to decide if one of those theories makes more sense or is a better explanation for what's happening. And so that's what we're going to try and do here. We're going to ask ourselves, is our data like this because package designs really do have different population mean sales? Or was it just random chance that made it occur? And for the ANOVA test, just like a lot of the other tests we've done, we're going to calculate a test statistic. In this case, it's going to be called an F statistic. And if that sounds slightly familiar, you may remember that for the equal variances test, we calculated something that said F equals, and then we had a way of calculating it. And like I said, we're not going to get into the details yet, but I'll just let you know that the test statistic for our actual data was 18.591. So I can go back here, and this is where this applet is telling me. So I don't know yet what kind of a test statistic that is because I've never done an example like this before, but in some way, this is comparing my data to some sort of null model. All right? So we're going to investigate this a little bit more. On the next page, what we're going to do is we're going to ask ourselves, what kind of test statistic would we get if nothing was really going on? So if there was no difference in the mean sales based on package designs, what kind of values would we get for this F statistic? And one way to do that is to take all of the different numbers for the amounts of sales and just sort of shuffle them up and then reassign them to different package designs. Because if I sold 11 cases using package design A, and package design doesn't matter at all, then if I used package design D, I also would have sold 11 cases. And by contrast, if this one sold 27 cases with design D, and package design really didn't matter, it would have also sold 27 cases with design B. So what we're doing is we're just shuffling up these numbers, we're recalculating the test statistic to see what does it look like when package design has no meaning whatsoever, or no effect whatsoever. And to do that in this applet, you can go up here and you can click on this button that says generate one sample. And I will click on it, and what you'll see is here is my sample. And when I randomly shuffled these up and calculated a new test statistic, I got a test statistic of 0.057. So right off the bat, that seems pretty different from the 18.591 that I saw before. But again, we know random chance, weird things can happen if I only do something once. So I'm going to do this a few more times. In the notes, I'm going to have you do it 10 times, but I'll just do a couple and then show you what numbers I got when I did this previously. So let me do it again. I got 1.462. It's a little bit higher. Do it another time, 0.548, 0.815, 0.082, and I could keep going. So when I did this earlier, these were the 10 numbers that I got. Everybody's 10 numbers should be different because we're all getting different random shufflings here. All right. So the first question is, does the test statistic that we got, 18.591, seem unusual when I compare it to these values? And for my 10 that I got, it definitely does. None of my 10 samples gave me a test statistic even close to 18.591. If you look through these, the biggest number that I got was right around 5. And I'm going to guess that for most of you, something similar will happen. You'll do this 10 times, and none of your test statistics will be close to 18. I don't know for sure, but that's what tends to happen. So it seems to me that if package design doesn't matter at all, 18.591 would be a really unusual thing to occur. But we've seen that, like I said, weird things can happen if you only do something, a handful of times. So let me speed things up. Instead of generating one sample, I'm going to generate 1,000 samples. And I'll click on this. And this is 1,000 samples plus the 5 that I did earlier. And you might notice that even when I did this 1,000 times, the biggest number I've seen is 10.3. Still quite a bit smaller than the 18.591 before. And again, when I did this earlier, I actually did this 10,010 times. And there was not a single time out of those 10,010 where my test statistic was as large as 18.591. Now again, remember that these were all generated pretending that package design doesn't matter. And when that happens, this is a really unusual number. Everything else looks very different. So if we assume the package design has no effect, what I saw, what actually happened when they did this experiment, was very, very, very unlikely. So we can now bring this back to the general concept of hypothesis testing that we've worked with throughout the semester. Let's say that these are my two hypotheses. My null model says there is no difference in population mean sales based on package design. And my alternative model says there is some difference in population means based on package design. Well, we saw something that would be very, very, very unlikely if the null model is true. Essentially, that corresponds to us getting a very, very, very small p-value. And so what we've done throughout the semester is we've said, if we get a very small p-value, that means we have really strong evidence to conclude that the alternative hypothesis is true, which in this case means there's very strong evidence that there really is some difference in population mean cereal sales based on the package design. So we essentially worked our way through this new type of test called an ANOVA test. We don't know how to calculate that test statistic yet. We don't know what the sampling distribution is or where our p-value is exactly going to come from, but you've seen kind of the basic structure. So through the remaining parts of Notes 15, what we're going to do is take this example and build on it. We're going to add in how we calculate the test statistic, what the sampling distribution is, and some of those things. But as we do that, keep in mind that this is basically the thought process that we're going to go through for each of these. And so you've already done an ANOVA test. You just need to fill in the details to know how to do future ones.